you can use any kind of energy storage in any technology, static or rotary. Yeah. Now both the type of UPSs, they are filtering and conditioning the power. As an energy storage, you have a battery or a flywheel. Now to continue your operation, you don't want to shut down your data center after a few minutes. You want to continue the process, so you will always have a standby or a continuous power genset in your facility. So both static UPS and rotary UPS condition the power. We have an energy storage, and then we have to combine with a standby diesel generator set. So this is the combination to have a long-term power quality backup. Yeah. So just a brief before we get into rotary, because some of you might have missed about the rotary UPS. We go first with the static UPS. A static UPS is called static because simply it uses static components to generate the power. So the output is generated using something called IGBT devices. In the inverter section, you have artificial sine wave generation using high frequency switching, and then you use filter capacitors to filter it, and you generate the output. So it's called static because there is no moving part generating the output. Yeah. That's why it's called static. It has nothing to do with energy storage. So if you use a flywheel, which is a rotating part of the static UPS, it doesn't become rotary. It is still static, but it is with a flywheel. Just a background before we get into the product details. On the right hand side we have a rotary UPS single line. We call it rotary because the output is generated using a rotating machine or something as called as a motor generator or a synchronous generator. So the definition of a rotary UPS is not with the energy storage, it is more with how the output is generated. So in a rotary UPS, like from Pillar and other manufacturers, we use a synchronous motor generator or a synchronous generator to generate the output. That is why they are called rotary. Any questions on this? So both are generating the output. On the rotary UPSs, the output is generated naturally. We don't have any switching devices. We have no capacitor filters. So it's a very simple design, and we generate the output naturally. It's a much purer sine wave output. Shall I go to the next slide?
I believe you will go in deep for the rotary UPS in this next slide.
We will try to, yes. Okay. We will try to do it. Yeah, that's what I mentioned. So the output is generated using a motor generator or a synchronous generator, and that is why it is called rotary, because we are generating it with a synchronous generator, not with any MOSFETs or IGBTs. So that is why it is rotary. So coming to data center needs, we know this terms from mostly all the products. We will try to fit in how Pillar fits into today's data center needs. Typically, we are focusing today in this presentation on the 4 points. That means that reduced infrastructure footprint. So we are trying to promote the flywheel technology, which is reducing your data center space drastically and gives you more rack space. And we are talking about flexibility and scalability. Today I am touching upon DE-RUPS, which is a electrically coupled rotary UPS, not a mechanically coupled, and how we are flexible. So we are able to give you different solutions depending on your data centers. On the reputational value, we are talking about Pillar as a company is able to give you different redundancy configurations to achieve the required reliability figures that you need. So we will talk about basically the flywheel energy storage, how we are able to reduce your carbon footprint, your air conditioning cost. This is the key points that we are focusing on. And the UPS, which is a rotary UPS, comes as a package from the manufacturer, and you don't have a separate genset, you don't have any separate energy storage, and it's mechanically coupled. So this one is a mechanically coupled diesel engine application, which we call as RUPS, which is of course available also from Pillar. Because normally if you have a gas-based source, then you are having your own generation, capital generation, and you just need a kind of a stabilization action. So these UPSs typically consider the fact that you are going to draw from the grid, and which is highly unreliable. You need to filter it and then have a long-term backup. So you use a standby diesel genset, which is normal. Also, it has to do with the response that is required. Yes, so I was going to explain that normally your data center will have the grid supply. This will go through the rotary UPS or a static UPS or a DRUPS, and it will filter the power quality and give to your loads. In case of any power failure, there is an engine which is coupled to the machine, and then this will take over. This is the conventional, one of the solutions available also from Miller, so which is a diesel rotary UPS. There are some advantages and disadvantages. That is the reason we are talking today about the DE-RUPS, which means that we are decoupling the diesel genset and the rotary UPS to give you flexibility to scale up and to maintain. Yeah. So this is a normal diesel coupled machine. So it's your UPS and generator, but all in a package. Yeah.
So in case of power failure, then the generator part will get
the engine will be started by the DRUPS, and the engine will take over the load. So it will all be seamless and automatic. So in a diesel coupled rotary UPS, everything comes as a package. You don't have to buy a separate diesel generator and an AMF and ATS. But there are some sites where customers already have existing diesel gensets available, and they would like to have the advantages of a rotary UPS. In that case, we are saying that you can always go for a rotary UPS minus the diesel genset, and both the diesel genset and the rotary UPS can work together. Yeah. Maybe I think it will be clarified in the next slide. So what we are saying is that it's possible to have a rotary UPS minus the diesel genset. That means your grid supply goes through the rotary UPS, which is conditioning the power. It has its own energy storage, which is a flywheel, and your standby diesel generator is a complete separate equipment, which was already available. So normally the grid supply is going through the UPS, UBP as we call it. That is the model we have from Miller. This is conditioning the power and feeding to the load. Your standby diesel generator is not in picture. Everything is fine. When the power fails, there is an energy storage which will bridge this gap, and this engine will take over the load.
How many times the storage can take over? I mean backup time. That means if my generator trigger after 5 minutes.
So before we offer this solution, we look at what kind of a genset it is, what kind of a governor it has. What, for example, in Cummins you have something called as a power command control. What is the version? So there are some aspects we look into before we say that yes, this is workable. And this is a normal diesel genset, 1500 RPM. We expect it to be automated, and considering that, we then design the energy storage. So we have different energy storages available. So we have something from 10 seconds right up to 45 seconds. So
Not
depending
more
on
than,
the
not more than a minute. Not more than a minute.
no, it's not required. Energy storage, conditioning, and all the switchgear, all part of one cabinet. So it reduces your footprint drastically.
Is
And
the highest rating possible?
2200 kilowatts for 50 hertz.
2000?
250 kilowatts, 2250 kilowatts as a single block. You can of course parallel multiple units. You can have them on medium voltage. All those combinations are possible.
How many units can be parallel?
Depends on what kind of configuration. So we have something called as an IP bus, where we can parallel up to 16 units on low voltage. So there's a lot of possibilities. That's why we say it's flexible and scalable.
Yeah. Yes.
So you can only have it in one direction. So for example, if you have industrial loads, the UPSs are meant for different applications. We are talking about data centers, but they go in different applications. And with a bidirectional flywheel, which is ours, we can also absorb energy. So if you have industrial loads, it can also absorb energy in case of regenerative drives. There is a big advantage of flywheel. The recharge time is the most important factor in a flywheel. So, a battery, if you discharge, you need several hours to recharge before you are ready for another outage. And in considering the recharge time, you always oversize the battery. In a flywheel, you don't need to worry about number of charge and discharge. So there is no cycles in a flywheel. You can charge, discharge any number of times. The recharge time is typically less than 2 minutes, 2 or 3 minutes, and within that duration, the flywheel is automatically recharged back. So you don't need to worry about the number of failures. You can handle many number of failures. The footprint is very small. We are talking about very low in X because we don't know what kind of energy storage you save a lot of space in your data center or other applications in terms of energy storage. You don't need any air conditioning for the rotary UPS. So we don't need any air conditioning. You can save a lot of air conditioning costs, which is recurring cost. You just have a natural air cooling. You just need to do one bearing change over the 20-year life cycle of this flywheel. It's required on the flywheel. On the batteries, you have different options available. 5 years. So the lifetime of the flywheel is more than 20 years. It's proven.
Static UPS, that is identity and SCR. So UPS harmonics. So rotary UPS does need any harmonics?
That's a good question. So I have not focused on specific specification comparison. We focus more on the concept that you should look at flywheels as an energy storage, reduce your air conditioning, but the specifications of a rotary UPS in terms of harmonics are better for both output and input without any filters. So we don't need any filters for harmonic correction. At the output, if you see, the output waveform is much more better than a static UPS, both on linear and non-linear load. And at the input, because it's a synchronous motor generator, it is always drawing sinusoidal current. So it is the harmonics are less than 3% always without any filters. So it's a natural behavior of all rotary UPS.
Hybrid vibration. Because there is flywheel and other.
We could show you size. You typically will not know that there is a flywheel. In terms of noise and vibration, you really do not cannot make out. The only applications we know are some special semiconductor plants where they need a certain vibration level. Yes, we have a lot of installations, but noise is also comparable. 1000 kVA rotary UPS is 77 dBA at 1 meter, and a static UPS would be in the same range, maybe 80 dBA or something in that range. So it's quite silent. I think this is a short summary of static and rotary UPS. Because it's a concept presentation, we didn't get into specifics, just a concept. The limitation of a static UPS typically is because of the devices. The devices have a certain current rating, and so you are limited by the block design. A single block maximum today available is a 500 kVA. If you need this 1100 kVA is actually multiple modules parallel together. It might look like one UPS, but it's multiple units. The reason we are pointing this out is that, like some other presentations also have said, the more number of components means lesser the reliability. In a rotary UPS, you can go much larger capacity as a single block. So we can go 60 Hertz, 3000 kVA, single block machine.